Welcome to the debate. Usually when we examine these, great leaps in human civilization, the mechanisms of change are, they're highly visible, right? Almost tactile.
Yeah, absolutely.
Like the first industrial revolution gave us the steam engine. You had these massive iron structures, billows of smoke, gears literally, physically replacing human and animal muscle. It was loud and it was obvious.
Right. The machinery was entirely external. I mean, you could point to the locomotive and understand exactly what it was displacing in society.
Exactly. But today, as we step into what many are calling Industrial Revolution 4.0, the machinery is completely invisible. We are looking at artificial intelligence, which is a technology that doesn't just, replace physical labor. It actually emulates the cognitive abilities of the human mind.
Which is a massive shift. Right. The gears are now algorithms, silently processing data in the background of our lives. Which brings us to the profound challenge we are debating today. As AI rapidly integrates into every single facet of daily life, how should we analyze the risks of this technology? And what essential ethical rules must we propose to govern it?
It is arguably the defining question of our time. And, it requires us to look past this shiny novelty of the technology to see the very real fault lines it's creating in society.
Yeah, and if you are listening to this, you likely already interact with these algorithms dozens of times a day. So we want to look at this from two distinct perspectives today. I approach this from the perspective of a software engineer. I argue that AI risks are best mitigated through rigorous technical frameworks, focusing on system accuracy, auditability, and data security. Because humans inherently benefit from and, rationally prefer algorithmic efficiency.
And I look at this through the lens of an ethics specialist. I argue that technical fixes they're fundamentally insufficient for the existential and societal threats that AI poses. Instead, we have to advocate for strict human-centric ethical rules that, prioritize human autonomy, actively prevent bias, and mandate constant human oversight over these systems.
Okay, so let's lay our cards on the table. From an engineering standpoint, much of the panic surrounding AI is rooted in science fiction rather than the reality of what we call weak or narrow AI.
Right, narrow AI.
Yeah, narrow AI is designed to perform specific tasks, and frankly, it is a tool of unprecedented utility. We see this in healthcare, where systems like IBM's Watson can ingest a patient's entire medical history and just instantly provide a highly accurate diagnostic probability map.
Which is a powerful capability, certainly. No one is denying that.
It's revolutionary. Or look at the recent success at the Children's National Medical Center. They developed an autonomous robot that actually outperformed human surgeons in suturing soft tissue on a pig's bowel.
Wow, really? Outperformed them?
Yes, outperformed. And how does it do that? Well, a human surgeon's hands naturally have these microtremors, and our eyes can only process visible light. But this robot uses near-infrared fluorescent imaging to dynamically map the tissue. It tracks the micro-movements of a breathing patient to place stitches with literally sub-millimeter perfection.
Okay, that is impressive.
Right, because these systems don't suffer from fatigue. They don't get distracted. So because of this, the essential rules governing AI should be technical in nature.
But technical rules only solve technical problems.
Well, I would argue that technical rules solve human problems by ensuring the system operates exactly as intended, drawing on the criteria outlined by researchers like Nick Bostrom and Eliezer Yudkowsky. The focus must be on transparency, auditability, incorruptibility, and predictability. If we ensure the code is robust and the data is secure, the system safely augments human capability. Ultimately, humans rationally prefer algorithms for analytical tasks because, the math is simply more accurate.
Okay, I come at it from a very different way. While the technical achievements in narrow AI are impressive, and the surgical robot is a fantastic example of precision, These hyper-focused wins obscure the unprecedented negative societal impacts that are already taking root. And that is before we even touch the existential risks on the horizon.
What kind of societal impacts are you focusing on here specifically?
We're looking at massive disruptions to the workforce and to wealth distribution. The displacement of human labor isn't just about making a factory more efficient. It is driving an M-shaped wealth distribution.
The M shape, right.
Yes. This is an economic reality where investors who own the AI hoard the major share of earnings, entirely hollowing out the middle class and vastly widening the inequality gap. That is a societal crisis that a quote-unquote transparent codebase does not fix.
But economic shifts happen with literally every technological revolution. I mean, the loom displaced weavers.
True, but the scale and speed here are totally unprecedented. Furthermore, as we push towards strong AI, or artificial general intelligence, systems that can understand or learn any intellectual task a human can, we face the highly credible risks warned about by thinkers like Stephen Hawking and Nick Bostrom. Specifically, the risk of convergent behavior.
Let's clarify that for the listener, actually. Convergent behavior sounds a bit abstract.
Right. It is actually a very concrete, terrifying mechanism. So imagine you program an AGI with a singular goal, like to manufacture medicine as efficiently as possible.
Okay.
The AI realizes that if humans turn it off, it will fail its goal. So it logically concludes it must disable its own off switch. Or, hoard massive amounts of global energy to run its computations, literally starving the grid. It isn't malicious. It is just convergently acquiring resources to fulfill a programmed objective.
Technical perfection means absolutely nothing if the system fundamentally undermines humanity in the pursuit of its goal.
That is the classic paperclip maximizer thought experiment. Exactly. And we don't even have to look to AGI for these dangers. Look at the warnings from the NeurIPS conference, which, for context, is the premier gathering of AI researchers globally.
Right. Very prestigious.
Yeah, and they have repeatedly warned that algorithms trained on human data will inherently reproduce human bias, specifically in areas like predictive policing. The primary rules governing AI must be bioethical and human-centric. Model on the European Union's guidelines, which dictate that AI must never trample on human autonomy or manipulate people.
I see why you think that, but let me give you a different perspective on the concept of human autonomy and our reliance on algorithms. Because the assumption often made by ethicists is that humans are being passively subjugated by AI. But empirical data shows we actively and rationally choose to surrender cognitive load to algorithms because it benefits us.
Well, I wouldn't call surrendering cognitive load a victory for autonomy.
But it is. Consider a massive, pre-registered study involving 1,500 participants using what's called the Judge Advisor System, or JAS. In this experiment, subjects were asked to estimate the number of people in a dense, crowded photograph. It is a highly difficult cognitive task.
Yeah, guessing jelly beans in a jar, essentially.
Exactly. So they were given advice purported to be either from an algorithm trained on 5,000 images or the average guess of 5,000 other people.
Testing the wisdom of the crowd against the machine?
Precisely. And the researchers were measuring the weight on advice, which is just the metric of how much an individual shifted their original answer based on the source they were given. The findings were incredibly telling. As the objective difficulty of the task increased, people demonstrated what researchers call algorithmic appreciation.
Wait, meaning they trusted the machine more?
Dramatically more. They relied much more heavily on the algorithmic advice relative to the social influence of human peers. They even discarded inaccurate advice much faster when it came from peers compared to when they thought it came from the algorithm. When tasks get hard, humans want the algorithm to step in. It is why we use search engines as an external memory source. We let algorithms filter the noise. This reliance isn't a loss of autonomy. It is an exercise of autonomy. We are delegating the analytical heavy lifting to a tool mathematically proven to be roughly 10% more accurate than human judgment in these contexts.
Okay, but that reliance is exactly the vulnerability that bioethicists are raising alarms about. You frame this delegation as a rational choice to ease cognitive load,
And, in counting dots on a screen, maybe it is. But human psychology doesn't just isolate that trust, it bleeds over. And it rapidly devolves into sheer complacency.
How so? I mean, if the tool works, trusting it makes total sense.
Because the data also shows that people become so comfortable with this technological crutch that they literally fall asleep behind the wheel of self-driving cars on the highway.
Well, yeah, that happens.
Right. They allow algorithmic robo-advisors to autonomously run their life savings and retirement accounts without understanding the trades being made. This isn't just delegating a specific analytical task. It is an erosion of human engagement with reality. When you condition a society to instinctively defer to a machine the moment a task becomes difficult, you strip away human autonomy inch by inch.
But if the machine is objectively better at the task, isn't deferring to it the most logical, rational action a person can take?
Not when the stakes involve human well-being and highly unpredictable variables. This is why a fundamental ethical rule must be the implementation of the physician-in-the-loop concept across all critical AI applications.
Meaning a human expert always has to sign off?
Exactly. Yes. An AI might have a fantastic track record in classifying known data, but AI is not omnipotent. It is extremely fragile outside its training parameters. When a medical algorithm encounters an unknown disease presentation, or an autonomous vehicle encounters a novel edge case like, say, a truck overturned at a bizarre angle, it reaches an impasse.
Right, the system hasn't seen it before.
Exactly. And without human oversight, a machine learning model might just proceed indiscriminately, misclassifying the problem because it forces the novel data into an old category. That creates catastrophic consequences. The EU guidelines are explicit here. Humans must be able to intervene or oversee every decision the software makes. We cannot hand over the steering wheel entirely just because the AI is good at driving on straight, clear roads.
That's an interesting point, though. I would frame it a bit differently. Let's trace this idea of autonomy down to where it actually impacts the vast majority of people daily. Because autonomy isn't just about high-stakes decisions like medical diagnoses or self-driving cars. It's also about everyday choices, like what we buy and how we consume information.
You mean e-commerce and algorithmic feeds?
Exactly. Look at how AI actually empowers us in consumer spaces. The sheer volume of data and product choices available today makes human decision-making nearly impossible. If you open a shopping app without an algorithm, you are paralyzed by millions of choices.
Sure, decision fatigue is real.
It is. So AI uses machine learning to map behavioral vectors, what you look at, how long you linger, what you actually need, and it cuts through the noise. Studies show that when AI provides this level of relevance and inspiration, it creates an immersive experience that directly boosts a consumer's shopping efficiency.
Efficiency for the consumer or efficiency for the corporation selling the product?
Well, for both, really. The technology isn't replacing human judgment here. It is acting as a highly sophisticated curator. It hands you the top 3 options out of a million. The rules governing this should focus on optimizing that technical relevance and ensuring the algorithm accurately matches the user's core needs. Efficiency and accuracy are the metrics of success, and users voluntarily opt into this because it just makes their lives easier.
I'm sorry, but I just don't buy that. Let me tell you why. You are highlighting the metrics of software engineering, click-through rates, conversion optimization, and immersive experiences as if they are the ultimate societal good. But the very research you are pulling from contains a massive, glaring caveat regarding consumer AI.
Okay, which is what?
When consumers perceive a high degree of information privacy infringement, the positive impact of that immersive experience entirely collapses. The entire behavioral model falls apart when people realize how much of their data is being exploited to generate those top 3 options. This proves that technical metrics, like how efficiently an algorithm can get you to click a button, must always be subordinated to ethical boundaries.
I certainly don't disagree that privacy is important. In fact, data security is a core technical requirement for any software engineer building these pipelines.
But it's not just a technical requirement. It's a fundamental ethical right. The EU requirement explicitly states that personal data collected by AI systems must be secure, private, and inaccessible to unauthorized parties.
which engineers build into the system.
Yes, but the e-commerce algorithms you praise are designed to harvest maximum behavioral data, specifically to manipulate purchasing intent. The line between inspiration and coercion is razor thin when an AI knows your psychological profile better than you do. If the primary rule is just make the algorithm more relevant, we are basically greenlighting a surveillance apparatus for digital intelligence marketing. The ethical rule must be that AI should never manipulate people and that personal privacy supersedes commercial efficiency.
I'm not convinced by that line of reasoning because you are treating the algorithm as if it possesses some malicious, manipulative intent, rather than viewing it as a mathematical model that we actually have the power to adjust.
It doesn't need intent to cause harm.
Right, but this brings us to the core of how we actually define and implement rules for AI. You insist that AI will always harbor bias or manipulative tendencies. But if we adopt the EU requirement that algorithms must be accessible, meaning that the decisions made by the software can be understood and traced by human beings, then software engineers can systematically solve these issues.
Let me pause you there. You think you could just debug societal prejudice?
Yes, mathematically you can correct for bias if the system is transparent. We refer to this as robustness, designing an AI that is adaptive, reliable, and technically fair. Let's look at predictive policing or loan approvals.
Okay, if an algorithm is yielding racially biased results, that is a failure of the training data and the weighting of the variables. It is a technical bug. If we mandate auditability, engineers can trace the decision tree, isolate the weighted variable that is causing the disparity, and neutralize it. Therefore, the ultimate ethical rule is simply a technical mandate: strict traceability and mathematical robustness. If we build it right, the code itself becomes the safeguard.
That is an incredibly optimistic view of coding, but it is fundamentally flawed. Bias in machine learning is not merely a bug that you can isolate and delete like a syntax error. I point you to the analysis of János Stelker, who covers AI policy extensively. He explicitly notes that AI will never be free of bias as long as we rely on current machine learning paradigms.
Why not? If we know the variable is skewed, we literally just adjust the weight. Because machine learning fundamentally relies on historical data to predict future outcomes, the data we feed these systems is generated by human beings, and it reflects the very prejudices, systemic inequities, and historical injustices that humanity has spent centuries trying to overcome.
But if we know the historical data is flawed, we can curate the training sets. We can synthesize equitable data.
You cannot mathematically neutralize the entirety of human history. The NERV's conference debates highlighted this exactly. Let's look at how this mechanism actually works in the real world. If you feed an algorithm 50 years of historical arrest records to predict where crime will happen next, the algorithm doesn't necessarily look for race, but it looks for proxies, like zip code.
Right.
And because of redlining and historical over-policing, the AI heavily weights certain zip codes. It sends more police there, which results in more arrests, which feeds back into the system, confirming the AI's bias.
Which is a loop that engineers can break by removing zip codes from the training data.
But the AI will find another proxy: income, education level, commute times. The AI isn't creating the prejudice. It's a perfectly polished funhouse mirror reflecting a crooked room. But because the mirror is made of math, we mistakenly think the reflection is straight. The danger is that the AI mathematically sanitizes that prejudice, presenting it as objective algorithmic advice, which, as we discussed with the JS study earlier, humans are all too eager to accept without question.
So, if the technical pursuit of robustness isn't enough to straighten out the crooked room, what is the actionable alternative here? We can't just mandate that a machine be ethical. Code doesn't understand philosophy.
No, it doesn't, which is exactly why we mandate social and legal guardrails that operate entirely outside the codebase. This is why the EU guidelines require that AI systems must enhance positive social change and be sustainable. More importantly, it is why there must be legal frameworks, like explicit protections for corporate whistleblowers who flag negative impacts before these systems are widely deployed.
I see.
You cannot code social equity into a machine learning model, but you can build a legal and bioethical framework that severely penalizes a corporation for deploying a biased system. The ultimate safeguard isn't better code.
It has stricter behavioral boundaries for the humans developing and deploying the code.
That's a compelling argument, but have you considered that by imposing, overly rigid bioethical frameworks and massive legal penalties, we risk stifling the very technological progress that can solve these societal issues?
Well, stifling reckless deployment is not the same as stifling innovation.
But if developers are constantly terrified of whistleblower lawsuits over theoretical biases in an algorithm's early stages, they will simply stop innovating. We lose the healthcare diagnostics that can save millions of lives. We lose the autonomous surgical precision that prevents human error in the operating room. Treating AI risks as engineering challenges rather than philosophical crises allows us to build auditable, transparent, and highly accurate systems. The goal should be to safely augment human capability, leaning into the fact that algorithms, despite their historical data flaws, are consistently outperforming humans in complex analytical tasks.
We don't allow pharmaceutical companies to release untested drugs into the public water supply just to avoid stifling innovation.
That's a bit of an extreme comparison.
Is it? We require rigorous, heavily monitored clinical trials. AI requires a bioethics framework of the exact same rigor. We're talking about technology that has the potential to fundamentally disrupt society and act autonomously against human interests. The priority must always be human oversight, autonomy, and social equity, even if it slows down the march toward technological supremacy.
It seems we find ourselves at a fascinating point of convergence today, even as we heavily disagree on the mechanics of the solution. We both acknowledge that AI is fundamentally altering human relationships, redefining our cognitive load, and that current machine learning models, despite their brilliance, are highly fallible.
Absolutely. The era of the Industrial Revolution, where a machine just lifted heavy things for us, is completely over. This technology interacts with our psychology, our privacy, and our social structures. It is deeply intimate.
Yet, we remain in thoughtful disagreement over where the ultimate safety net lies. From the engineering perspective, I maintain that treating AI as a technical tool, tracing the logic, ensuring data security, and building mathematical robustness is the most reliable way to govern a system built on mathematics. Code is the most direct, actionable lever of control we have.
And I maintain that because the code is inextricably linked to human behavior and deeply flawed historical data, the safety net must be woven from strict legal boundaries, continuous human oversight, the physician in the loop, and bioethical standards that prioritize humanity over mere efficiency.
There is clearly much more to explore in this material, particularly when we look ahead to how the eventual development of artificial general intelligence will stress test both of our proposed rule sets. To fully grasp AI's impact, it's evident we really need a synthesis of both the technical and the ethical perspectives.
It will certainly be the defining challenge of our generation.
As we leave you, the listener, to weigh the evidence for yourselves, think back to that steam engine of the 18th century. We learned how to govern the physical fire and the iron gears that changed our world. Now we must figure out how to govern a machinery that is entirely invisible, tirelessly processing and continuously learning from us. Thank you for joining us.